go ahead and switch to our graphing calculators and write these functions out. Okay, so here is a Wabbit calculator. And so what I need to do is first graph the function. So I'm going to go to y equals right over here, and I'm going to graph both functions in y1 and y2. When I'm done entering it, I just press the graph, and it should look a lot like our function. Okay, so now what I need to do is find out where A is. So A looks like it's the intersect of both lines. So I'm going to go to second, trace, intersection, or intersect. First curve is the blue curve. The second curve is the red curve. Because there's only one intersection, it actually doesn't matter if I need to move to that point, so I can just press it where it's at. And it looks like the intersection point for X is 0.616. We don't want to round this. We want to keep that. So what I'm actually going to do is I'm going to get out of this by pressing second mode, which is quit. And then I'm going to go to X. I'm going to press the store button right here. And then I'm going to write alpha A. Okay, by doing this, what I'm actually doing is I'm keeping that value for X that we just found in the location A. Saves you a lot of typing. Okay, I'm going to go back to my graph. And now I want to find where the red line intersects the x-axis. So I'm going to go to second, calculate. I want to find the 0 because that's where it crosses the x-axis. Right now it's on the blue function. I don't want that, right? So I'm going to press up to get to the second function, which is the red function. Now left bound, I just want to be on the left side of that intersect. Right bound, I want to be on the right side of that 0. So anything underneath it, I could stop here, whatever, doesn't matter. In between these two dashed lines should be where the red line intersects the x-axis, which we can clearly see it does. And it comes up to be 1.386. Of course, we want to keep all of it, not just the first 4 digits. So what I need to do is do what we did before. Quit this, take my x value, and store it to alpha b. Okay, when I do that, press enter. Now I have those values stored in A and B. I even can recall them later. So if we remember, before that was our equation, I can actually put that in my calculator right now. So if I go to math, and I go down to, it says FN integral, sorry. I'm going to press 9 instead of scrolling. And I'm going to plug it in from -4. And the beauty is I can just write A. I don't have to write that long digit. And you know what's crazy? The square root of x plus 4, I can literally type that in, or I can just write y1 because we've already typed it in. So I'm going to go to the y variables. I'm going to press variables or vars. Go to y variables, click on functions, click on y1. The actual variable is x, and that's the first part of our integral. I'm going to add it to the second part of our integral. Press math, go down to 9. Start at A, go to B, and now I'm going to press variables. Y variables, I want it to be the function that I wrote down, but instead of y1, I want to put in y2. Go to the side, press X, and now I have exactly what I wrote over here, right here. Press enter. And that is my value for part A. So 7.544 is my answer to part A. Now we're going to move on to part B, where we're trying to find the volume of the solid revolved around the line y equals -3. So when we revolve around a line, we need to look at the graph a little bit better. We need to figure out what that does to the function. So I'm going to make that line y equals -3. I know I'm going to rotate around this way. And I need to figure out what the spaces are going to be. Okay, so I need to find out what the radius is from here all the way up. And I need to find out the hollowed spot. Because now we actually have a volume that's going to be taken away from the outer volume. So we have an inner function and an outer function that has two different volumes because this is now gutted away from the outer shell. Okay, so let's think about what the first capital radius should be. And then we got to figure out what's being gutted away. Okay, so the problem with our capital R's is that there's two parts of it still, like it was for the area. Okay, so from 4 to A is going to be the first function y1, and then from A to B it's going to be the second function y2. But it looks like from -4 to B we can subtract that uniform cylinder, or the volume that's going to be created, away. Okay, so I'm going to write the formula down and then I'm going to talk about it a little bit more. Okay, so I wrote down what I was talking about before. Capital R from -4 to A is 3 plus y1 because we have to travel up 3 to get to the x-axis. And from the x-axis to this line is the value of y1, which is the square root of x plus 4. We don't actually care because it's stored in our calculator, so we can recall that later. The R between these two spaces between A and B is actually going to go up to the line y2. It goes up 3, and then from the x-axis to y2, and that's why that R is going to be this. The hollowed out radius, the radius that we're going to get rid of that volume of that cylinder, is uniform from the whole thing, and so it's just 3. Okay, I'm going to go ahead and pause again and write down the volume in its integral form. Magic, that is the volume that we need to write down. Okay, because we have to split it off in two parts and subtract the hollowed out volume, that's what our equation is going to be. Because we have to find the volume and not just set it up, we have to actually plug it into our calculator. By the way, if we didn't label y1 and y2 as the functions provided, we would have to actually plug in those values instead of leaving it y1 and y2. Like we did up here, actually write out the functions that use the abbreviation. But since we just want to find the volume, and if this was an FRQ, this wouldn't be good enough. Like they probably wouldn't give you points if you just left it like this. So we're back to our calculator. Okay, so actually most of it is written up here, but we're just going to do it, write it out all the way again. Okay, so I'm actually going to cheat a little bit. I'm just going to scroll up and grab those functions. Okay. So on your graphing calculator, if you want to insert something, you see that ends right here? That means insert. So I'm just going to go to second, insert, and I'm going to plug in pi. See how it's blinking? That means I can insert in front of it. So I'm going to go second, square, or the caret. I'm inserting that pi right there. This right here is going to be 3. So I need to do my parentheses. 3 plus the variable of the function y1 and parentheses square. Right? So that's the first part. I'm going to go to the second one. I'm going to press second insert. Now it's blinking. You see how it's hollow there? I'm going to put pi in front of it. I'm going to do parentheses 3 plus variables, y variables. I want the function y2. And parentheses, I'm going to square that. And I'm going to be subtracting away. Now I actually got to go back and put the integral all the way down to 9 from -4 to b. So I'm going to press alpha b right there. 3 squared, which is 9 pi. And the variable is x. Okay, that's everything. All I have to do is press enter. My calculator does all the heavy lifting. And it's 108.1459. You can actually put in 2 answers. You can put in 180.145 or you can put 180.146 because it can round up technically. Since we actually don't care which one you use, always do the one that's cut. Don't really worry about rounding because sometimes your brain goes mushy on FRQs. Okay. Finally, we're trying to do a quarter circle cross section of this function perpendicular to the x-axis. Okay. So this one is actually not terrible. It's just weird, right? So the cross section that we have for our function, okay, we're going to go from the x-axis and we're going to go up to that. So what we've actually done is we're going to use what we did for the area as our base. So we have 2 bases. We have a base from -4 to a, and we have y2 as the base from a to b. Okay, so I need to find out what my area function will be, right? And since we're looking for quarter circles, the area of a quarter circle is going to equal pi divided by 4 of the base divided by 2 squared. Now I know it's the base divided by 2. I'm so sorry. It's just the base squared. Okay. I know it's the base squared because since it is a quarter circle, the radius is actually the full length of the base, not like the semicircle. Right? So all I have to do now is write the equation out. And I'm going to do that to save time off screen. Okay, so we have, it looks a lot like the area, except now we have the base of from -4 to a, right? And the base from a to b look like this. Remember, all I did was plug in the different bases for the section of the area of the region R. Sorry. Okay. If you already label what A and B is, that you can leave it like that. Otherwise, if you wanted to write it out, it would look like this. Okay, where I actually had to put the values for A and B into the correct locations. This is all for setup. You don't have to do anything else. Okay. Hopefully this was helpful. Mrs. Aro speaking and gone.